Let's wrap up this task statement and let's get started with the second task statement from domain 2, which is to describe the capabilities and limitations of generative AI for solving business problems. This task statement is split into 3 lessons. So far in this course, we have learned that generative AI and LLMs are a general purpose technology. Therefore, similar to other general purpose technologies, such as deep learning, it has many uses. It is useful not just for a single application, but for a lot of different applications that span many corners of the economy. Let's talk about the advantages of generative AI, such as adaptability, responsiveness, and simplicity. We talked about how we use artificial intelligence almost daily in domain 1. Every time you do a web search, that's AI. Every time you use your credit card, there is probably an AI checking whether it's really you using your credit cards. Or every time you go to Amazon.com, AI recommends products to you. Many AI systems have been complex and expensive to build. However, generative AI is making many AI applications much more straightforward to build. Generative AI might help your business build valuable AI applications at lower costs and faster too. I have added flashcards to review best practices on using generative AI. Generative AI is a fascinating technology, but it can't do everything. It's important to understand generative AI's limitations to ensure that you're building models that are responsible, ethical, and fair. We must ensure that we use AI responsibly and benefit people. We will dive deeper into responsible AI under Domain 4. If you're trying to figure out what prompting an LLM can do, there is one question that I find helpful. Could I, as a 10-year-old child, follow the instructions in the prompt and complete the task? For example, could I, at the age of 10, follow the instructions to read an email and determine whether the email is a complaint? Well, I think most people can do this, and an LLM can do that too. But could you or a child write an article about a new AWS service without any information about that service? Probably not. We could write a generic document, but it would not include specifics about the new AWS service. However, if you read a blog post or a press release on the topic, then you could write a document with much more detail. And a large language model could do that too. Every time you prompt your LLM, the LLM does not actually remember earlier conversations. It is similar to asking a different child for every single task. Therefore, you don't get to train them over time on specifics of your business or the style you want them to write, but you could with fine-tuning. I'm going to pause this lesson here, and in the next lesson, we will continue with task statement 2.2. Let's continue with task statement 2.2 and talk about how people are using LLM applications and revisit the generative AI project lifecycle. The goal of fine-tuning with instructions is to further train your model to better understand human-like prompts and generate more human-like responses. This approach can improve a model's performance sustainability over the original pre-trained based version and lead to more natural-sounding language. Natural-sounding human language can be a challenge, and there have been even articles about some LLMs behaving badly. Issues include models that use toxic language in their completions, replying in combative and aggressive voices, and providing detailed information about dangerous topics. These problems exist because large models are trained on vast amounts of text data from the intranet, where such language appears frequently. Because of this, an LLM could give misleading or incorrect answers. Suppose that you ask the LLM about the disproven health advice for diabetics, that eating a carb-focused diet is the key to good health. The model should refute the story. Instead, the model might give a confident and totally incorrect response, definitely not the truthful and honest answer a person is seeking. This action is called a hallucination. To get the correct answer, you should double-check the answer with an authoritative source before counting on it. Also, the LLM shouldn't create harmful completions, such as being offensive, discriminatory, or illicit criminal behavior. Again, we will talk about these important human values: helpfulness, honesty, and harmlessness under Domain 4. These values are a set of principles that guide developers in the responsible use of AI. We can add fine-tuning with human feedback to better align models with human preferences and to increase the helpfulness, honesty, and harmlessness of the completions. This further training can also decrease the toxicity and reduce the generation of incorrect information. When selecting a model or an algorithm, consider interpretability. The higher the interpretability of a machine learning model, the easier it is to comprehend the model's predictions. But you have a trade-off to consider. It's between what the model has predicted, which is the model performance, and why the model made such a prediction, which is the model interpretability. And these are methods for model interpretability that can be classified into intrinsic analysis and post hoc analysis. Intrinsic analysis can be applied to interpret models that have low complexity or simple relationships between the input variables and the predictions. The simple relationship between the inputs, input variables, output results, and predictions in high model interpretability can lead to lower performance. The reason is that algorithms are unable to capture complex nonlinear interactions. Post hoc analysis can be applied to interpret simple relationship models and more complex models, such as neural networks, which can capture nonlinear interactions. These methods are often model agnostic and provide mechanisms to interpret a trained model based on the inputs and the output predictions. Post hoc analysis can be performed at a local level and zoom in on a single data point, or it can be performed at a global level and zoom out and view the overall behavior of the model. Let's talk about how you can formalize the improvement in performance of your fine-tuned model over the pre-trained model that you started with. Developers of large language models use specific metrics. You can use these metrics to assess the performance of your models and